Hello, hello, and welcome back. So we're going to go over some more fun examples for sum difference of cubes. Alright, so I'm looking at example C. So that'd be 81m cubed minus 3. So I'm looking at this. First question I always ask, is there a GCF? And here, I'd be like, wait a minute, 3 and 81. Well, let's double check, right? 81 divided by 3, does it go in evenly? Yeah, it does. So there is a GCF here. Alright, so what we need to do now is we need to factor that sucker out. So I'd be like, okay, so 3 is the GCF, so we pull it out. And so 3 times what gives us 81? That'd be 27. You can also just say, 81 divided by 3, that is 27. There's no m on the second term, so we know 3 is the GCF there. And when we factor a 3 out of our second term, we get a 1. Remember, it's always multiplied by 1. Alright, so now we're taking out our GCF. Now we ask our next question, right? Do we have perfect cubes? Yes, we do. Remember, 27 is on that list of perfect cubes, right? Also, 1 is on that list. And m is being cubed 3 times. So I look at A and I look at B, right? Of this first term, what is being cubed? Well, we said 27 was the perfect cube of 3, and that m cubed is the perfect cube of m. So what's being cubed is this entire portion here. It's 3m times 3m times 3m, right? And then we look at B, and I'd say, alright, well, there's just 1 here, so what's being cubed here? A 1. 1 times 1 times 1. Alright, and then I'd say, okay, sum or difference? Well, I look at this and I'd say, excellent. It says subtraction. Subtraction is the same thing as difference. Alright, so I look at my difference of cubes formula and I bring it down. That's a minus b, a squared plus ab plus b squared. And I'd say, alright, Shazam, I know what a is, I know what b is, you plug it in. So a is 3m minus b, which is 1. A squared, which is 3m squared, plus 3m times 1, which is just 3m, plus b squared. And then we just need to simplify that. So on the first parenthesis, 3m minus 1 isn't getting any more simplified than that. On the second one, you have to be very careful. Because it is multiplication, you can distribute the square. This is not the same as addition subtraction. Okay, multiplication, it's fine. Because think about it. 3m squared is the same thing as 3m times 3m, right? What's 3 times 3? 9. M times m? M squared. Alright, so please keep that in mind. And then we have 3m plus 1 squared, which is just 1. Alright, no like terms, we can't combine anything. Whoa, why do my boxes love doing that of late? It's fine. There you go. And that is difference of cubes. Let's do another. D, I'm looking at that and I'm thinking, alright, first thing is GCF. Is there GCF? Yeah. Right, I look at 5 and I'd say 5 can go into 40. So there is a GCF of 5 here. Are there any variables? Nah, they don't both share a variable. So 5's the GCF. We pull 5 out of 5a cubed, we're left with just a cubed. Pull 5 out of 40, we're left with 8. It's like the most awkward 8 ever. Hold on. There we go. 8. And then I ask myself, are these perfect cubes? Well, is a cubed a perfect cube? Yeah. How about 8? Also, yes. So they are both perfect cubes. We are good to go. Then I look at this little subtraction and I think subtraction. No, wait, difference. That is a difference. So we look at the difference of cubes equation. Whoa! Alright. When we're looking at that, now we need to identify what's A, what's B. Now, irony here is that the variable is actually A. So I'm looking at this and I'd say what's being cubed in that first term? A. So A is A. Big shocker there. Alright, B, what's being cubed in our second term? Well, what times what times what gives us 8? That's a 2. time we just plug it in. So what luck is that our a is a, we just keep those the same. So a minus b, which is 2, a squared minus a times b, so a times 2, which is 2a, plus b squared. And I'm just going to rewrite that as 4, because at that point we don't need to do any simplification or any kind of like fancy writing, because it's already good to go. Alright, let's look at example E. Is there a GCF? No, there is not. Then I ask myself, cubes. Is there any perfect cubes here? Yeah, we got a perfect cube. V cubed is a perfect cube. Is 25 a perfect cube? It is not. Alright, remember 25 is not a perfect cube, but it is a perfect square. Right? Difference in sum of cubes only works if you have cubes. If you do not have cubes, you ain't factoring this using difference in sum of cubes, right? And because it is not a perfect cube, it's not what you want. We cannot deal with this. We're done with it. Just take it out, right? So v cubed minus 25. We can't do anything with it, right? We can't do our trinomial factoring because this is the third, not a square. Cube. This is a cube, not a square, right? We can't do anything there. So we can't factor this any further. There's no GCF. We can't do grouping because there's not 4 terms. So that is done. Circle it or box it. Move on. All right, next thing we do is... or first thing we do, I should say, GCF. Do we have a GCF here? The answer? Yes. Right, look, we have 4 and we have 16. Does 4 go into 16? Yeah, it does. Alright, so I pull out a 4 as my GCF because we don't share any variables. And we're left with an x cubed minus 4. I'm looking at that and I'm like, okay, excellent. Do we have perfect cubes here? Well, x cubed is a perfect cube for sure. Is 4 a perfect cube? Nope. This is literally the exact same thing we just had. 4 is not a perfect cube. It is a perfect square. We do not have a perfect cube. So, because it's not a perfect cube, we have factored it as far as we possibly can. We've taken that GCF out. So that is our final answer. Alright, we don't write the original equation. We want to factor it as much as possible. And if a GCF is as far as you can take it, it's as far as you can take it. So we take that, write it out, and move on. Alright, last but not least, we have example G. Now I look at this and I say, is there a GCF? Alright. Now I'm looking at this and I'd say, no. There is not a GCF. Because remember, 125 is a perfect cube of 5 times 5 times 5. Right? Is there even one 5 that's going to fit into 64? No, it's not. Right? Or you could have thought of it like lesser number first, right? 64 is 8 times 8. Right? Which 8 ain't going into 125 in any way, shape, or form. It's an even number, which means that pretty much all of the factors of 64 will not be fitting. 3 might have, could have gotten close potentially, but even if you checked it, still wouldn't have worked. Alrighty, then I look at the variables. We have x's and we have c's. Are those the same thing? They're not. So is there GCF? Nope. Okay, do we have perfect cubes here? Now, be very careful. 64 is an interesting number here. Yes, it is a perfect square. 64 is a perfect square, but it's also a perfect cube. Right? 64 is 8 times 8, but if we're thinking perfect cubes, then 4 times 4 times 4 will give you 64. Right? And then 125 is 5 cubed. So yes, we do have perfect cubes. So let's just identify our a's and our b's, and I'd say, okay, what's being cubed in our first term here? Out of everything here, what's being cubed? We just said 64 was a perfect cube before. Right? And what's being cubed here? The x, right? X to the third is the same thing as x times x times x, so x is being cubed. And 125, what's being cubed there? A 5. C cubed? A C. Alright, then I ask myself, alright, sum or difference? Sum. So from here, we use the sum equation. So it's just a copy paste. So a plus b, a squared minus ab plus b squared. Alright, you know what a is, you know what b is, plug it in. So a is 4x plus b, which is 5c. And then we have 4x squared minus 4x times 5c plus 5c squared. Alright, then all we have to do is just wear it down, simplify it out. So we have 4x plus 5c, and from here, 4 squared is 16, x squared is x squared, right? 4 times 5 is 20, x times c is xc. 5 times 5 is 25, c squared is c squared. And that's it, right? There's no like terms to be combining here, so there's nothing else we can do. And that's it. That's probably as complicated as sum and difference of cubes is going to get, so just make sure you, hardest thing is really just identifying what's being cubed, because once you do, you just plug it in, simplify it down. Alright, there we have it. Thanks so much for watching. Let me know if you have any questions.